Hey, I'm going to talk to you about the Hardy-Weinberg equation. The whole equation is p squared plus 2pq plus q squared equals 1. Q squared stands for our homozygous recessive, and I've written two lowercase a's, where q is just one lowercase a, and that's one recessive allele. P is our dominant uppercase A, so it's one dominant allele. And I want to say here that P plus Q equals 1, and that's something we're going to come back to when I give you a problem. Going on, P squared, which is two uppercase A's, would be our homozygous dominant, and then 2PQ, represented by an upper and a lowercase letter, would be our heterozygous. Okay, so here's our problem. A sample population of homozygous recessive is 36 out of 100. Calculate the following A through E. Now, it's important to remember when asking for a frequency, you're going to give a decimal. When asking for a percentage, then give a percentage. A decimal is always better than a percentage when you're trying to calculate. So the first question says, what is the frequency of a homozygous recessive, which is lowercase a, or q squared from our equation? So we pull out 36 out of 100. So 36 over 100 is 0.36. So that is our homozygous recessive. Then they ask for our homozygous allele, which is just q or lowercase a. So we're going to take the square root of 0.36 and we get 0.6. Then they ask us to calculate the frequency of dominant allele, or uppercase A, which is equivalent to P. So we know that Q plus P equals 1. So if we take 1 minus 0.6, we get 0.4 for our dominant allele. D is a frequency of the homozygous dominant, or P squared. We get 0.4, and we're going to square it, and we get 0.16 for our frequency of our homozygous dominant. And then on E, they're asking for the frequency of our heterozygous, which is 2PQ. And remember, we say 2, we multiply the PQ by 2 because we could get PQ or we could get Q then P, and that's why we use a multiplier of 2. So we extract from B and C 0.6 and 0.4. So we're going to take 6/10 times 4/10, and we get 24. Now we have to multiply that by 2 to get 48/100ths, would give us a decimal of 0.48. Another way you could do it is just take 2 times 0.4 times 0.6 and you get 0.48. And that's it for the Hardy-Weinberg equations.